Okay, now let's look into the another very interesting concept, or rather I would say it's one of the property of certain sorting algorithm. So this is one of the property of some sorting algorithms. So this property we call it as the stability. And by the way, this is not a new sorting algorithm. So stability is simply a property that some sorting algorithms have. Right now, before we understand why we need of a stability, let us first understand what the stability means in a sorting algorithm. Right, so for that I just want to show you a Wikipedia page. So right now I'm at the sorting algorithms page, and inside that there is a subsection called a stability, right? And here you can find a very nice diagram explaining the concept of a stability in detail. So I'm expanding this image so that we'll understand much more better what the stability means, right? Now imagine we have set of chords. So there are four set of chords. So this first chord contains the number or an integer 7, and I don't know what the symbol mean, and assume that this is the black color this is the black chord and the number is 7. Then we have number 5, then 2, and the color of this chord is red, and we have one more chord with the number 5. Suppose I want to sort these chords based on the numbers in an increasing order, right? So the task here is I want to sort them in an increasing order, right? Now there are the two possible outcomes you could able to see in this image. So this is my output 1. Let me write it down as output 1, and this is my output 2. Let's see the difference between both of them. So in output 1, in an output 1, you could able to see that we have the digit 2, then 5, 5 and 7, and even in the output 2 also have the same thing, right? So let me write it down here, 2 comma 5 comma 5 comma 7. This is my sorted order, and 2 5 5 7. Now what is the difference between both of them? But both outputs are correctly sorted based on the numbers. In both the cases, the numbers appear in the increasing order, something like this, 2 comma 5 comma 5 7. However, there is the key difference between the output 1 and output 2. So in the original input, the red 5 appears before the black 5 here. And what about in case of an output 1? Output 1, red 5 comes first, then black 5 comes next. So that means in output 1, the order is preserved. Let me write it down here. Order is preserved. What about in case of an output 2? The order is reversed, right? So if you look at the output, the black 5 come first, then before the red 5, right? So the black 5 comes first before the red 5. What does the stability mean by looking at this example? So a sorting algorithm is said to be stable if it preserves the relative order of elements with the equal keys. So in simple words, if two elements are having the same value, so in this case 5 and 5, so two elements are having the same value and one appears before the other in the input, then the stable sorting algorithm will keep them in the same order in the output. So in this case, red 5 comes first, then we have black 5, same like my input. Now from these two cases, I would say output 1 is a stable and output 2 is not stable. Output 2 is not stable. So what does not stable mean here? If a sorting algorithm produces an output, so it produces an output where equal elements change their relative order compared to the input, right? Then the algorithm is not stable. So you can clearly see the input and output of this second case. Since the relative order of the equal elements changed, that sorting process is not stable, right? Now let's restate this clearly. Now let's look at to these arrows so that you can clearly understand. Look at the arrows in the diagram, right? In the input, the red 5, let me change the color here. So let me change it to a red. In the input, the red 5 appears before black 5. In the stable output, the red 5 still appears before the black 5. Now you can see the arrows here, right? But in a non-stable sorting algorithm, however, something different happened, right? Even though the two 5s have the same value, their order changes. In the input, the red 5 appears before the black 5, but in the output, the black 5 appears before the red 5. So this means the input order of repeated elements has not been preserved, right? Yes or no? So from this example, we can clearly understand that this is the a stable one, and the output 2 is not stable. So if their order changes, the algorithm is unstable. If the order doesn't changes, it is a stable sort. Now what about insertion sort algorithm? So insertion sort is the stable sort algorithm. From the intuition we discussed earlier, insertion sort inserts the each element into the correct position without disturbing the relative order of the equal element. That's why the insertion sort is a stable algorithm. So as of now, we just learned what stability is, but why stability is important, why it is used, how does it help in the real world scenario. Now let me give you a simple real-time example. Imagine you have a data stored in the form of a table, something like this. Imagine this is my table, and this table contains two columns. So first column is a price, and the second column is a name. Second column is a name, and this table contains that information. I have information about connectors or adapters of the devices. Let's say I have Apple device, right? And the price of this device is, let's say, $23, right? And let's say I have another laptop, Acer, and the price of this device is 31. And I have Asus, and price of this device is not device, it's a connector, right? So it is $31. Then we have HP, let's say 40, and Lenovo, right? And let's say the price is 60. Now let's perform this sorting in two different ways. Now in the step 1, what I'm gonna do, I'm gonna sort this table by using the name, right? So we first sort the data by name, not by price. So here we can also do the sorting on the text one or the string also. How the sorting will happen in case of a string? So it will perform alphabetically. We can also call it as the lexicographic sorting. When we sort by name, we compare the characters. First it will compare the first character, right? And if the first characters are matched, then it will go and check the second characters. That's how the sorting will happen in case of a string. So after sorting alphabetically by name, my table become like this. Let me draw the table here. So again we have two columns. One of the column is price and another column is a name, right? After sorting, which string will come first? As we sort them by name, first one is an Acer, then we have Apple, then we have Asus, right? Then HP and Lenovo. And the price of an Acer is $31, and price of an Apple is 23, and price of an Asus is 31, and HP is 40, and Lenovo is 60. Right? Now the data is sorted purely based on this particular column called a name. Now again, what I'm gonna do now is I'm going to sort them in the basis of price. I'm going to sort the entire table on the basis of price. So this is where the stability become very important for us, right? If we use a stable sort algorithm like an insertion sort, then items with the same price will keep the order they had before. Now let me do that. Let me draw the table so that we'll get a better idea here, right? So I have two columns. The first column is the price and the second one is a name, right? Now once I do the sorting operation on this particular column called a price, my satellite data will also getting changed, which we already discussed at the first part of or the initial video of an insertion sort algorithm, right? So items, if you look at the output or by looking at this table, here we have the two devices, but these two devices are having the same price. The cost of if two items both are having the $31, right? So in our example, we have the two items with the price 31. Since we previously sorted by name, Acer comes before the Asus now, right? Because if I want to meet the stability order, the relative order, so I'm going to keep Acer first, right? So in case of first, Apple will come. Once you sort the entire data on the basis of a price, the first entry will be Apple. The next we have Acer and Asus. Both are having the same price, $31 and $31. So if you want to maintain the stability, you have to maintain the same order. The relative order should be the same. So Acer and Asus. So 31, 31. And we have HP, right? Then we have Lenovo, 60. Since we previously sorted by name, Acer comes before the Asus. If you now sort by price using the stable sort, the order between the Acer and Asus will be remains the same. The relative order is same. This is extremely important in databases and multi-level sorting. This is one of the real-time example where we use the stable sort.